Now let's do certain linear regression examples. So first of all, we need certain data. So here I had created a small data. So the name of the file is alcoholstrength.txt, and this one is, one has to place it at the particular place where is your working directory. So here one can place it here, just a moment. Suppose this one is a file here. Let's see. Alcohol strength file, it is there. It is having the .txt extension here. Okay, because when I had created this file, so I had saved it as .txt extension. .txt extension means it means notepad extension. So one can see the name alcohol strength.txt. The extension one has to check it out. So this is a text extension file here. So I had saved it, and now I'm closing it. So this one is a file, and later on I had just called this file from the place where I had stored this file. So I had saved this file here into the C drive users del documents, means this one is my current working directory. That's why I had stored it here. Okay, so one can check it out with get working directory, that where is your working directory. From there it will start picking it. So here, suppose here I'm just placing my file. This one is the alcohol strength.csv. One can see this file here, this file. This is the file, placed it here at this particular location. So while calling it, I have to give the same location. And here also I had loaded the file, this particular file here, from this location only. It came from this location only. So one should know that where is the file actually. Now, what we can do, we can open one of the script here. So what I can do here, suppose here I'm just going file, new file, click it here onto the R script. Once we'll be clicking here onto the R script, this file, R file will be opened, and here we can write all the linear regression related materials here. So how to proceed with here? First of all, what steps we are going to do with the linear regression? The same I had discussed earlier with the PPTs as well. So here it is. We have to define the problem. We have to load the data, then explore the data, prepare the data. We can split the data into the train test so that the training data could be learned by the model, and testing data could be used as the validating the model for the prediction of the model. Then we have to train the model by using the training data, and later on we can use the testing data just for the prediction of the model. So we are going to take these steps in a very step-by-step way. So first of all, you can check it out that what is the current working directory. In that place, one can save the data set, right? So suppose here get WD, get working directory. So if you run this command, you will be getting where is your place for the current working directory. Suppose this one is my place, so you can just check it out your place as well. Where is your current working directory? C drive users del document. So the same place here I am just taking to put the data set as well. So where is the data set? The same place I had just chosen to put the cell here, data set here, so that it could be much more easier for me to fetch out the data set here. So one can see this is the data set at the same location, C drive users del, where is my current working directory, same one. So now, because this is a text data, I had already told you that this file is a text data file. So here, whenever I'm calling it, so I have to give it here read.table. So with the help of read.table, I can just fetch it out the data, as it is a text data. So wait, here one can see this one is a text file. I had loaded it here from the file with the open file, and later on I'm using the same file which is located at C drive users del document at this place, alcohol strength text here. So I'm fetching this file here because this one is located at this position. And we have to take care for the path also. These slashes, backslashes, I have to use it here. Once it is done, header equals to true means one is just saying that one has to take the column header. The default column header which is provided here, that is going to be used. Once it is loaded, we can see it here. So let's run this command now. This one I'm just running it here. So here it is showing all the data. This is the data coming in here, alcohol and the strength. So certain data are there, certain values are presented here. So suppose here I want to plot it here. Plot it here. So data $alcohol, comma data $strength, I want to plot it here. So here it is just showing certain plottings also. With the reference of the plotting, we can just understand, see here, it is declining. So declining means it is showing certain, with the plotting only, certain negative relationships are present with the alcohol and the strength of the body. So I can just check it out with the core also. This one is an inbuilt method inside our core. It can find out that what is the correlation between the alcohol and the strength here. So this one is the statistical method here. If I click it here, it is just showing certain negativity. It is showing here minus 0.929. That there is certain negative present into the correlation of alcohol and the strength data. Okay, so now let's do here linear regression. So to see that what are the linear regression, we can take the help also, help lm. Just we can see if I'm running this command, what happens. It is saying lm, fitting linear model. LM is used to fit the linear model. It can be used to carry out the regression. Okay, so we can use this to find out the variance and analysis of the covariance between the two data. So here, this LM formula, we have to use it here. So I'm using the same one here. How? Let's see now. So to apply the linear regression here, I have to give LM. Inside the linear regression, I just told earlier also that inside the LM, I have to pass two things. Here, I have to pass the dependent and the independent variable, that which relationship to which particular columns I need the relationship. And here I have to give the data source. What is the data? So here I'm just giving, okay, just show me that, because here I have to give Y. Y means dependent variable, and here this is a tilde sign. Here it will start applying the linear regression. Here I have to give X. X is the independent variable. So into the Y here, into the Y, the body strength is there. So I will be considering strength as the Y and alcohol as the X here, X. So I will be considering this alcohol into the X here, and will be considering strength as a Y. Y means dependent. So strength is dependent on the consumption of alcohol. So that's why I had written here ln strength tilde sign alcohol. So strength is Y, alcohol is X, and this way I had represented it. So find out the linear regression between strength and the alcohol, and where is the data? Where is the data source here? So we have to give here that data is the parameter. Data is equal to that, where is the actual data lying it here? So we are saying the data is lying into this data. Which variable? This is the variable where we had extracted the data of alcohol strength.txt into the data variable. So the same data variable we have to put it here. If this name is some other name, suppose datas, so I have to write it here, datas. The same variable we have to put it here. Once it is done, then we can run this command. So it will start applying the linear regression model, and in the backend it is going to apply the same relationship formula. Y is equal to A plus BX. This is A plus BX plus E. It is going to run entirely with the help of this library. This library consumes this mathematical relationship in the backend. So we need to worry only with the linear regression model this library only, that's all. So here it is just running, I'm just running it here. So it has run. Now let's see abline R. Abline R is basically, it is going to make the line between the data. Means abline means it will just give the line. So it is showing me the declining line here. It is showing me the declining line, that it is showing the declination is here. It means with maximum consumption of alcohol, the strength is declining by this line. We are getting this idea from here. Now here, let's see the coefficient of R. So if I run this, okay, it is just showing these data. What these data representing? These coefficient means the slope, which is represented by this equation, y is equal to a plus bx plus e. So this b is the slope, or I can say this one is the coefficient. So this coefficient is represented by this one, coefficient of R. This is represented by the same one. So what it is saying, it is just saying, it is just giving me the two value, the intercept and the coefficient of alcohol. So intercept means this value 22.02, 22.02 will be appearing here, and alcohol, this one is appearing here. This one minus 0.3267. This negative coefficient is appearing here. So if it is giving the negative coefficient itself, means that whenever this negative coefficient means that whenever there is a unit increase into the X consumption, it means whenever there is a unit increase in independent variable, it means whenever there's a unit increase in alcohol, +1 increase in alcohol value. So what will happen here? In this Y, the strength is negated by the slope value. The strength is negated by this value, minus 0.3267. So 0.3, this one minus 0.3267. This value will be reduced from the strength. So this shows us that whenever there is a unit increase in the value of alcohol, so that will be impacting negative minus 0.326 value into the strength of Y variable. So it means strength is declining with increase in consumption of alcohol. So this formula is working in the back end here when LM is working. And this coefficient is representing the slope value, which is negating, showing the negative behavior. And here, if I'm just clicking it here, the summary of R, I want to see certain more statistical summary here. So we can see here, because see this one, this formula we had applied, okay, in the backend it has been applied. It is showing certain residuals. Residuals are what means these are certain errors are there, minimum error, first quantile, median, third quantile, means percentile, these are the values, maximum values. Let's see the coefficients here. These are the estimated coefficient of intercept, efficient coefficient of this one is estimated coefficient of alcohol, the same coefficient, minus 0.3267, the same value. These are the errors happened in both the T value and the P value. Certain very statistical data are coming here. And here it is showing with these star significances that both are very important for the strength. It means these attributes or the features are important. They are quite important or significant for the output variable, means Y variables, dependent variables. Right, so that one it is showing it here. So, and errors are present there. So it means Y is equal to A plus BX if it is there. So these are showing the errors also. So this errors is represented by these errors, standard errors it is just giving. And this A is just coming by the intercept, this one, 22.02. And this alcohol, this coefficient is coming for this slope basically. So this one is entire working in the backend here. So this represents that the consumption of more alcohol is reducing the strength here. So this is showing this relationship by using the linear regression. Now here, how to do the prediction here. Now let's do certain prediction here. If, because how this equation is going to be settled in the backend here, suppose here, because I'm conveying like y is equal to a plus bx, so this particular a value is this value 22.02, okay, plus b. What is the b here? The b is here 0.3267, okay, it is there. Now suppose here I'm just giving new values to the x, means I'm just giving the new values to the x, means input variable here. So I can just give new values. Suppose here I am just giving, if the alcohol consumption is 37.8, if the alcohol consumption is 37.8, it means suppose this is alcohol consumption 37.8 nearby, approximately here, if the alcohol consumption is here. So let's see what would be the y. What would be the y here? So what we can do here, we can just calculate this equation and this is going to show me the y here. So if I'm just taking the same prediction here with the newer data and I'm just clicking onto the run button. So what it is saying, 9.6. So here it is just showing 9.6. So here nearby it is showing the data would be approximately here. So it is just showing that if the consumption is 37.8 nearby, so what would be the strength? That one will be the 9.6 nearby. At this location, the strength will be there. Suppose here I'm just putting with a more data. I'm just saying instead of this now, suppose I change the data here. I'm just saying, okay, what would be the Y strength if the consumption is 41.6. Means alcohol consumption is 41.6. Nearby means if it is there, approximately it is here. 41.6 I'm just considering here. So let's see what would be the Y here if we are taking it. So if I run this equation, because 41.6 I had kept it here, click it here. It is just saying 8.4. Let's see what is the 8.4 here. So see here 41.6 is the alcohol consumption. This one is the slope. This one is the intercept, and it will give us the Y. Y means dependent variable. So it is just giving the Y. Y means strength. 8.4. So 8.4 is nearby here. So we can say this way, approximately this way, 8.4. So it is saying if you are consuming nearby 41.6, 41.6, so the strength of the body will be 8.4 based on to the data. So in this way, the LM is working, the linear regression is working in the backend here. So here we need only to call the linear regression libraries directly. So this one is one of the very simple examples I have taken. Now let's do certain more examples here, as I had taken very simple example here. Now there are certain basically more data set into the R here. We can choose those data set here. Suppose here I am having one of the data set here, car data set. Suppose here I am just writing it here. Data sets, as soon as I will be typing it here, data sets. If I press it here, it will be start showing many of the data sets which are present here into the R. Many data sets are there. So I can just call any of the data set here currently. So suppose here there is one of the data set cars. I'm just running it here, right? And here I'm just clicking it here. So here certain data are appearing. Let's see what is these data now. Here Here there are certain speed and the distance traveled. It is presented here into the dataset cars. Now let's see here. If I run these lines head cars, so it will be showing me first top 5 cars here, top 5 datas here. So let's find out the linear regression between the relationship of the distance travel along with the speed. So here we can consider distance as the y as the dependent variable and speed could be the independent variable. So how I can write it here? Simplified way. I can just take it as a y is equal to a plus bx. Already we know that. And here the y variable would be the distance traveled. And what is the independent variable? The independent variable will be the speed here. The speed would be the independent variable, independent and dependent variable. The rest of the things will be calculated by the model itself now. So here there are certain internal method for the plotting purposes here. Suppose scatter dot smooth. This one is the internal. Here I want to make the plotting it here. Let's show me the scatter plot here along with the car's speed and the car's distance as the x and y. So here it is showing certain relationships of linear. So linear, with this linear relationships, we are getting the idea that it is showing certain positive relationship because the data are moving towards positive. So it is showing certain positive relationship. It means with increase in speed, we are covering the good distance. So here we are getting this idea. We can use the plot method directly also. We can do that also. See, if I'm just clicking it here, plot method, it will be showing me data in this way. Now let's find out the correlation. So what we can do, let's run it here. So I'm just clicking it here, correlation between the car speed and the distance traveled. Here it is showing, okay, 0.80. 0.80, it means it is showing the positive relationship between the car's speed and the distance traveled. With this also we are getting there a certain positive one. So that's why 0.806 nearby, the positive relationship, it is just showing it here. Okay, now here I want to see that what is the relation. Let's use the linear regression now. So I'm taking it here as the y variable for the distance along with the speed as the x. And where is the data? Data is here into the cars here. This one data is equal to cars means this one is the data source. I'm using the LM linear regression model and storing the resultant in any of the variable. One can consider any of the variable. I'm just running it here and just looking. So here it is just showing the data here, certain coefficients it is just showing, and intercept also it is showing. So if we check it out, intercept is -17 and speed is 3.9. It means it is showing there's a positive relationship hit here, 3.9 nearby. This one is the coefficient coming it here. It means y is equal to a plus bx. So into the b here, 3.9 is the consideration coming here as the slope. It means whenever there is a unit increase in speed, it means +1 speed is increased. So y plus 3 means p distance is covered by 3.9 extra. It means whenever +1 is increased into the speed is increased by +1. So 3.9 will be added into the distance y. So it is showing the positive correlation here. Now here, if I want to see the summary, so it will be showing all the summary along with the detail here. And here it is just showing the estimated coefficient here. The estimated coefficient here, speed coefficient here. And these are the standard errors here. There are more statistical data it is giving. And with these three star, it is just showing that this particular variable, speed variable, is significant to the model. It is heavily working into the model very positively. Okay, so this is showing. Now what we can do here, there is another data set, empty cars. Empty cars. This one is already available. As soon as we are writing it here, it will be called here. So here, if I am calling it here, there are many inputs are there, many variables are present inside the empty cars, such as miles per gallon, cylinder, displacement, horsepower, many other input variables are present. So we can take them and we can just consider that miles per gallon, we can just take miles per gallon as the Y, and we can take any of the X variable. Suppose here I can just take displacement as the X variable, that what is the relationship between the miles per gallon and the displacement, or what is the relationship between the miles per gallon or the gear we are changing or the horsepower we are putting it here. So any of the variable, we can just make it as the X and we can find out the relationship between the Y variable mpg miles per gallon. So we are doing the same thing here. Model 1 means any variable where you can store the linear relationship here. So I'm just running it here. And I'm just, let's look out the summary here. So into the summary, what it is conveying. Into the summary here, it is conveying that coefficient. Let's see the estimated coefficient. Okay. Little bit say these are the intercept estimated coefficient here. Minus 0.04 is coming here. Certain errors are also given. Certain statistical values are coming it here, but it is saying the displacement is quite significant into the output here. We can take right now, like what we are doing, we know that here we are taking only one variable. It means we are trying to find out the relationship of mpg with displacement. This is one of the column which we are taking it here. So we are considering it as a y, it is the x here. But at the same time, if I want to consider more than one column here, so how to represent that? So suppose here I'm just taking it as a y. Right now I'm just considering only one, but instead of this, I want to take more. So what I can do, simply I can write the y variable, tilde sign, and only dot operation. Once I'm writing the dot operation, dot means it will be automatically taking all the input columns into the data set as the x. As the x, all these will be the input variables. Okay. So how it will be working in the backend? So it will be working into the backend as just like y is equal to a plus b1 x1 b2 b2 x2 b3 x3 plus b4 x4. So this one is what? This one is the same linear regression, but it is with a more than one variable. So here in x1, what will come? Automatically this value will come. So it means this one is the independent variable of cyl. What is the x2 here? X2 is the second variable, suppose displacement. So displacement will be the x2 here. X3 will be HP, horsepower will be there. X4 will be the second next one. So this one is the DRAT and moves on. So here it will be taking all the variable into the consideration. And what are these? B1, B2, B3, B4. These are the coefficients of cylinder, coefficient of displacement, coefficient of HP, coefficient of DRAT here. So these are the independent coefficient related with the each variable. So it will work in the backend in this way. So as soon as we are writing with dot, it will be considering all these input variable during working of the equation here in the backend. So simply I will just write it here. One can see model 2, I'm just giving the new name here, LM MPG, and I'm just considering only dot. So with this dot, it will be taking out all the, see this dot, it will be considering this as a y and all these as the x1, x2, x3, x4 and goes on up to xn in the backend. So only dot we have to put it here. Now let's run it here. If I'm running it here entirely, so here it is showing this one into the summary. It is running it here and it is showing the summary. And it is showing all the related coefficients with each and every x1, x2, x3 input variable. So intercept estimated value, it is showing cylinder coefficient, displacement coefficient, HP coefficient, drag coefficient. So these are the values coming for different input variables. Like weight is there, minus 3.71. Suppose here displacement is there, 0.0133. Certain gear is there, 0.6 here. AM is there, certain 2.5. So these are the coefficient of all these x1, x2, x3, x4. These are the residual error. These are the t value and the p value, which are the statistical data along with these columns here. So in this way, one can work with a linear regression. So one can work with a single variable also, and one can work with more variables as well. Now let's take like how we can do it with a train test split. As I had told you earlier, if we are doing the work with a train test split, because till now I am doing all the work very simplified. Now how to make the train test split also with their data. So here we can call the particular data, any data. So salary.csv I'm just calling. Let's see here, salary.csv. This is one of the files as a salary.csv. If I'm clicking this file here, right click, open with Notepad, it means it is going to show you the data with Notepad here. So here, if I'm just checking it out, certain years experienced, salary and health. It means three variables are there with year, experience, salary and the health, and the data are given. This one is a comma separated value file. This one is, one can see comma separations are in between, comma separations are in between. So this one is a comma separated value file here. Now I'm just calling this file here. Here I can run this file. I can just check it out one by one, the years experience and the salary. So here, if I'm just clicking it here, data, let's move this one. I'm just running it here. So here it is just showing three variables are present here. Year of experience, salary and the health. So three columns are there. So in this one, we can make the train test split by using the CA tools here. So here I'm just clicking it here. If I want to say individual variables, so name of the data, dollar, column name here. It is showing it here, data of the salary, I can do that. Now there is no need to install this package CA2, that one is already available. Even one can see, click it here onto the packages. If one is clicking it here only, CA tools. If one is doing it here, click it here, CA tools. So one can have this CA tool availability onto the R so that it can be used. So all the functionalities inside this CA tools, we can just do it here. Just if you click it here, only this much we have to do it. Now how to call it? You have to call here only with this name, this one, library CA tool. Once it is here, if you run this library CA tools, all the basic functionality will be available onto the R now. Now inside it, we need to split the data. For splitting the data, we need to write only, once the CA tool is present here, now we have to write sample.split. Sample.split will split the data here into the ratio which we need for the training and the testing here. So if it is there here, so this much data will be splitted here. So here I'm writing sample.split. Inside it, we have to write data dollar salary. It means we want to split this one. Which one? Data, and split ratio, we can just put it here. 0.7. So this is also a parameter I have to give, that which part you want to split, and here split ratio, inside the split ratio I need 0.7 means 70%. So it means 70% splitting is required. So 70, and automatically this would be the 31. So this one is the training set, this one is the testing set. It needs to be split the data. Done. Once it is done, let's run it here. It has split the data. Now here, see here, certain it is just showing certain splitting here into the data. Now, if I want to say what is the training data, so only I have to write subset data split is equal to true, means wherever the file has splitted, this sample or split function has split all the data. It has split some of the data with training, some of the data with testing. So those data are represented internally into the system with the true and false. So here we are just taking okay. Just take the training set, from that subset, take the training set which are splitted with the true values. So we are just taking subset, take from the data, split is equal to true. You can see it here. If we check it out here, some of the data are splitted with true and false value. So suppose here we want to take all the data which is just given internally with the true values. So here we are taking it as a training set. So we just run it internally. So here it is just showing that this one is the training set, and one can see the training set which is taking it here. It will be taking very randomly. Suppose here first row, second row, third row, fourth row, fifth row, seventh row, 10th row. It has taken for the training. Internally it is splitting on its own. And later on, suppose here I want to see what is the test set here. So we are taking test set data split is equal to false. Means wherever the false is there, just to give it here. So here it is just giving me the remaining data out of 10 rows, because the total are the 10 rows here into the salary.csv file. So here it is just giving me the test set. One can see it here. Here it is just saying 6th row, 8th row, 9th row, and these are the data it has split. So nearby 7 data it has taken for the splitting of this one, 70%. Remaining 3 data as a 30% it is considering internally for the testing. So this data is for the testing and this data is for the training. If we check it out from here also, one can see the training set and the test set. See here, it is also giving the details here. The training set, see the variable here, training set. One can check it out, the training set here, it is just giving 7 observation of 3 variables. And if I check here, the test set here, the test set is just giving, this one is a test, 3 observations of 3 variables here. So it means these are the 3 observations, these are the 7 observations it is giving. So the data is split here. Now let's train the data here with the training set here. So we are just running it here and we can check out entire summary here. So we can just click it here now. This one we can just see it here. So here it is just showing, it has run the model here. We want to see that what is the relationship between the salary and the year of experience. So here it is just giving the year of experience, this one, okay. Let's see the summary of the model here. Okay, so here it is just giving, this one one can see coefficient estimated and intercept it is there, and year of experience it is giving here. These are the coefficient giving it here. So what it is saying that year of experience is behaving positively to the model here. Okay, so in this way we can do this work. Now there is one more. If I want to, because this one is the training only here. We have done it with the training set. One can see I had passed the training set here into the data while delivering the training here. So now if I want to see what is the predictive, means what is the prediction, what is the validation of the model by giving the newer test set data. So I'm just providing the test set data here. Inside this test set, now we are predicting the model, that how well this model will work now with the newer data set. So here it is just giving you the predicted value. So if I check it out, this predicted value, here the same model name, we have to use it here, the same one. New data is equal to test data. Test data is the same data which we'll be using for the validation here. So here it is just giving, these are the new values which are coming for what? Salaries. So because it is trained onto the salary and the year of experience, years of experience here. So here it is just showing that this would be the salary like 52,370 or 54,690. These are the salaries of those year of experience which we had provided during the test set. So these are the prediction it is just giving. So in this way, we can work with the linear regression. So one should remember whenever we need to explicitly put the data into the training and test, so we can use the CA tools and directly sample.split. Inside that we can get the data and the split ratio, that how much split we needed here. So like 0.7 means 70%, 0.8 means 80%, and the remaining data will go to the testing set here, 30% or 20% accordingly. And then we can train the model by using the training set, and we can do the prediction by making the testing set. So in this way, we can work with a simplified linear regression. Thanks.